229-3239 if you're located in the United States or Canada. Call other countries, please dial 1-408-435-7088. To eliminate background noise, all phone lines will be muted for the duration of the event. Next slide, please. Please feel free to ask questions at any time during the event by clicking on the question mark icon on the voting toolbar located at the top of your screen. Please be sure to address your question to the default selection in the Q&A so that it goes to all panelists. We will address as many questions as possible during the Q&A session following today's presentation. This event will be recorded, and a link to a replay of today's webinar will be emailed within the next few days. Before we begin today's presentation, I would like to introduce the speaker, Chris L. Chris is currently a customer support manager and software trainer at Certara. I'll now turn it over to Chris to begin today's presentation.
Thanks, Suzanne, and thank you everyone for attending today. Good morning or good afternoon, depending where you're calling from. So this presentation will be of the Phoenix software developed by Certara Corporation, and the core component I will be presenting is Win-on-Win. Win-on-Win is an industry standard preclinical PK software, and this is going to be presented in the Phoenix platform, which is designed for ease of use and some powerful new plotting data tool capabilities and ease of use and sharing work with colleagues. So on my screen is the Phoenix application. The latest version is version Phoenix Win-on-Win 6.3. And when using Phoenix, the first step is always to use a project. So I can either open a new project or load an existing project. In this case, we'll start with a new project. And the project has a structure to it. So in the object browser on the left at the top, you will find the project name. There is a data storage container for input data. Custom code such as scripts or custom models can be stored here. The tables folder is for outputs. And DQL rules is a place where one may do DQL replacements, the low limited quantification rules. Companion documents such as Word documents or PowerPoint slides can be stored here. And then the main workflow is where all of the analysis steps are performed. So in this first example, this will be a two-period crossover study with two different formulations. And to get data into the Phoenix application, use the File Import menu and locate your input data set. So typically this would be an Excel file, it can be a CSV file, or it can be a save file from an earlier version of Win-on-Win. Upon clicking Open, there's an import preview screen. In this case, the data are partitioned into columns, where each column has one data element in it, and some of the columns also have units associated with the PK. So the time is in hours and the plasma concentration is in nanograms per milliliter. So in my import preview, we'll go ahead and check the Have Units row box. In Win-on-Win, the column headers can have associated units, so that when one performs calculations, the appropriate units get applied to the output parameters. So with these import options selected, next click Finish and Open. And a brief examination of this spreadsheet shows that there are a number of different subjects identified by the patient column, the subject IDs. The next column, treatment, has identified the formulation name. There's a tablet formulation and a capsule formulation. And then the subjects are divided into two different sequences. Sequence 1 gets the capsule first and then the tablet, and sequence 2 gets the tablet first and then the capsule, hence the crossover design. The period identifies which period the subject got the associated treatment, and then the time and concentration columns will actually be using these to make plots and do PK analysis. So I'll start with some exploratory plots. There's some very sophisticated plotting tools in Phoenix. Let's start by visualizing the subjects and comparing the different treatment types. So I'm going back to the data sheet, right-clicking and selecting Send to Plotting, and then XY Plot. So in the plot options, there will typically be a main mapping panel at the top over on the right, where one can identify which columns get assigned in the plot to construct it. And then the Y column will be the plasma concentration. And then in the, you can also use this other information, such as the patient and treatment group, to sort of profile or separate out different plots. So when one uses a group variable, that will take all of the levels within the column and make a figure legend with different colored lines. So for example, if we map patient as the group variable, you will get a legend identifying the patient number. And let's go ahead and compare the treatment side by side. In this lattice conditions section, I will choose the lattice column, which will, at each level of the treatment, make a separate plot, but on the same page. And then since this is PK data, down in the bottom options panel, we'll select the y-axis and select logarithmic to make this a semi-log plot. With these mappings and options selected, I will go ahead and execute the plot. And just as a brief comment, this button is what tells Phoenix to produce output. So whenever you want Phoenix to run something and produce output, it's always the orange cog icon at the top of the application. So upon clicking execute, we have a semi-log plot. On the right portion is the figure legend identifying the different subject IDs. And since a lattice column was chosen, the capsule treatment appears on the left plot and the tablet on the right plot. And the side-by-side comparison is easily obtained. Coming back to the object browser, and this item named XY plot is referred to as an object in Phoenix. And in order to organize my analysis, I can rename the object. So I will call this plot overlay subjects by treatment. You can also do some similar plot. For example, if you want to look at the individual subject, come back to the input data set and select it. Right-click and select Send to Plotting and XY plot. And again, choosing time for the X variable and plasma concentration for the Y variable. And this time, we will use some different selections. So I will start with grouping by the treatment. And let's start with subject as a page sort. So when using the page sort, each patient will get their own individual plot on a page. Remember to set my y-axis to logarithmic, and then execute the plot. So with the page sort selection, each subject has both treatment plots overlaid, and the subject gets their individual page. And it's very easy to visualize multiple subjects all on one page by using the latticing features in the options. So the bottom option is Plan Panel. I'm selecting Plot, and then uncheck Bind Lattice to Data. This allows you to change lattice selections. And let's do 3 lattice columns and 4 lattice rows. So with a simple selection, this updates on the fly and allows you to visualize more than one subject per page. And one of the nice features of Phoenix as well is if you want to look at a specific aspect, such as this plot output, you can double-click the output plot to pop it out into a window and then maximize the window. So this is a nice matrix plot topology of TK profiles. Okay, and in my object browser, I'll go ahead and rename this. So I'll call this one the lattice plot by subject. Moving from left to right, so starting with the Cmax, which is the maximum observed concentration, and the associated time Tmax. The area under the concentration time curve from the dosing time to the last observed concentration is referred to as AUC last in monotonous. And it is the sum of the trapezoids drawn underneath the concentration time curve at each observed time point. In the terminal phase, there is a log linear regression performed to calculate the latency parameter, which is the negative of the slope of the regression line. In literature, you would often see this referred to as KDL, the elimination rate. And this elimination slope is then used to extrapolate beyond the last concentration to draw a final trapezoid down to the collision and calculate the AUC acidity. And there are basically 6 nonparticle TK models provided with Phoenix that are determined by the route of administration, extravascular, infusion, or bolus for both plasma and serum data. Dosing inputs can be either imported from a worksheet or entered manually using an internal worksheet. And some of the options that are possible include selecting the terminal elimination phase with the mouse, specify the AUC calculation and interpolation method from the partial areas under the curve, specify therapeutic range, and set preferred output units for the PK parameters as well as the preferred parameter names. So given this background, the next step in Phoenix will be to set up a non-compartmental analysis of these different subject profiles. So I'll start by going to the input data set, right-click and then send to. From the submenus, choose the NCA and toolbox group, and then choose NCA. So this is an NCA object. And the NCA object has a main mapping panel, like the other objects in Phoenix. Required columns are the time and the concentration. So I will map those using these radio buttons here, time and plasma concentration. And then the sort column is used to profile the data. So what happens is, when you map something as a sort, I'm going to run a separate NCA analysis, for example, for each patient. And since each patient got more than one treatment, we'll go ahead and also map treatment as a sort variable. The carry variables are an optional selection. What this will do is it will take the input column and carry it through and report it alongside with the output parameters. So we'll put the sequence and the period as carry variables. Underneath the setup tab, next I will move down from the main mapping to the dosing. In this case, the input sheet does not have the doses recorded, so I will use an internal worksheet to enter dose values. So that's this little Use Internal Worksheet checkbox a bit to the right. Upon checking this, one can select the dosing source. If both of the dosing sources are selected, one would need to enter in individual doses for each patient treatment combination. So this will be the appropriate approach given each patient treatment combination with a different dose amount. If all of these are uniform, if the dose is 100 milligrams for every combination, you can click Rebuild, uncheck the dosing source, and then you only need to enter in the dose one time, and this is now assumed to apply to all subject treatment combinations. So this is a 100 milligram dose administration at time 0. In the bottom options panel, there is a dose options section where one can toggle between the routes of administration. For these profiles, this will be left as extravascular, but you can choose also IV bolus, IV infusion, or dosing combined if there is a mixture of IV and oral data. To assign dosing units, type in the units in the bottom unit box and then press enter. And this is a single dose study. So up in the top portion, the tau is being left blank. One would enter in a tau. This is for a multiple dose study, where tau is the time interval between administered doses. But for the single dose study, we will leave the tau empty. And then coming back down into the options section, for the AUC calculation method, the default is linear trapezoidal with linear interpolation, and these are rule sets for how to draw the trapezoid. Since this is PK data, I would choose a linear log trapezoidal method for the extravascular data, where the linear trapezoidal rule is used up to the Cmax, and the log trapezoidal rule is used after Cmax. There are some additional options you can choose in MCA, which include the units. So for example, you can change the units are governed by the input data. The hours come from the time column and the concentration column as well. Units were nanograms per milliliter. So those will determine the output parameters. And you can actually choose different output parameters if desired. For example, you can report volume in liters and clearance in liters per hour by editing this preferred unit for the associated parameter. Each parameter names worksheet allows you to determine which parameters to report in your output. So NCA produces many output parameters, some of which may be of more of interest than others. So if you want to not include certain parameters, you can change this include in workbook menu from yes to no, and then yes no selection can actually be dragged down. So I will make a few selections of which parameters I want to report. Thing you can do in this section is edit the preferred name. So in the Wadoma jargon, if we look at the 8th parameter here, it's HL_lambda_t, that is derived from the terminal phase regression and is more commonly referred to SD half-life. So if rather than using this jargon term, I want this output column to be called half-life,